Welcome to the third module of Unit 1, BBA Rural Management. In the second module, we have seen about number sequences and we have learnt about arithmetic progression. There, we have seen how to calculate n terms, nth term and the sum to n terms. Now, let us start solving this problem now. We are given the sum of 7 terms. So, here n is 7. The sum to n terms, that is S7, is 35. A is not known to us, that is the question asked to us now, and the common difference D is 1.2. Let us substitute these values in the problem. So, 35 is equal to 7 by 2 into 2 into A plus 7 minus 1 into 1.2. This gives me 70 2A plus 6 into 1.2, which is 70 by 7 2A plus 7.2. Or 10 is equal to 2A plus 7.2. Now, or this is 0.8, 9 minus 2 divided by 2, A is equal to 28, 2.8 by 2, which comes to 1.4. So, the initial term A is 1.4. So, by now you should be quite comfortable in doing the problems using the formula. So, you need to understand the problem and then substitute the relevant terms and solve the problem. Thank you. Now, let us move to the next problem. Reading the problem now, 3 numbers are in AP, their sum is 15 and their product is 18. Determine the 3 numbers. Now, here there is a technique now. What is, how do you find to, how do we calculate this problem? How do we do this problem now? We have to choose these numbers, these 3 numbers in such a way that the middle term is A. If the common difference is D, the number preceding it will be A minus D. The number that follows will be A plus D. So, we will choose those numbers as, let the 3 numbers be A minus D, A and A plus D. It is also given to us that their sum is 15. The sum A minus D plus A plus A minus D plus A plus D is 15. Now, this minus D plus D gets cancelled. You have A plus A plus A, which is 3A, which is equal to 15. This gives me A is equal to 15 by 3, which is 5. So, here the initial term is 5. Now, it is also given to us that the product is 80. Now, we have to find the numbers. So, to find the numbers, we have to find the common difference D now. Let us do this now. The product is 80. Product is given by A minus D into A plus D, which is equal to 80. A minus D into A plus D is A square minus D square. So, this is A into A square minus D square, which is equal to 80. We have already arrived at A. So, A is 5, A square is 5 square minus D square is equal to 80. So, this comes to 25 minus d square is 80 by 5, or it is 16. So, d is 25 minus 16, which comes to 9 d square. So, d is equal to plus or minus root of 9, which is equal to plus or minus 3. Now, a is known to us, a is 5, d is plus or minus 3. Having known this, what are the numbers now? The numbers are a minus d, a and a plus d, that is how we choose them. So, let us take either of them and find out. First one is a 5, I take d as 3. So, this is minus 3 into this is 5, this is 5 plus 3. This comes to 2, 5 and 8. So, these are my numbers. You can also choose minus 3 and check your answer. Let us solve the next problem. Read the problem first. Find the sum of all numbers between 0 and 207, which are exactly divisible by 3. Now, this is an arithmetic progression. The common difference is 3, and what is the initial term here? Initial term is 3. So, the series is 3, 6, 9, so on till 207 being the last number in that series. So, the initial number a is equal to 3, your common difference d is equal to 6 minus 3, which is equal to 3. What is the last term over here? The last term is 207. So, L is equal to 207, or t nth term is 207. We know the formula for Tn. Tn is equal to a plus n minus 1 d. Now, let us find the value of d in this using this formula. I will substitute the values. Here L or Tn is the same, which is 207 is equal to a is 3 plus n is not known to us, that is what we are going to find, n minus 1, d is again 3 in this case. So, this is 204 is equal to n minus 1 into 3, or 204 divided by 3 is equal to n minus 1, which gives 1668 is equal to n minus 1. So, n is equal to, here 68 is equal to n minus 1. So, n is equal to 68 plus 1, which gives me 69. So, n is 69. The question asked is, you have to find the sum of all the series here. The sum of all the series is, now your a is, the initial term is 3, d the common term is 3, and n is 69. So, we have to find Sn or S69, which is equal to, the formula is n by 2 into 2a plus n minus 1d. I will substitute these values over here. It is 69 by 2 into 2 into a plus 69 minus 1 into 3. Let us solve now. This is 69 by 2 into, this is 3, which is 6, plus 68 into 3. That gives me 69 by 2, 6 plus 4, 18, 204, or this is 210 into 69 by 2, which is equal to 69 into 105, which is equal to, the value of this is 7245. We move on to the next problem now. Let us read the problem. The problem goes like this. The T1 is the first term in this. The T1, T12 and Tn are in AP are 4, 31.5 and 376.5. Find the number of terms in the series, that is the first question in that. Number 2, sum of all the terms, and C, the 80th term, that is T80. Now let us do the problem now. We are given that A is 4, T12 which is A plus 12 minus 1 into D is the common difference. So now here A is known to us, which comes to 4. Let us find D from this. T12 is given as 31.5, 4 plus 11 D. So now let us calculate the value of T. Transpose this 4 to this side. It comes to 31, 27.5 is equal to 11 D, or this is 55 implies 55 by 2 is equal to 11 D. So D is 55 by 2 into 11, which comes to 5 by 2, or this is 2.5. Now the common difference D is known to us, it is 2.5. The first question is asked, find the number of terms in the series. Also the last term is given as 376.5. Now let us proceed. Let the terms be n. So Tn is equal to 376.5, which is equal to, here A is already known to us, which is 4 plus n minus 1 D. D is 2.5. So transposing 4 to on this side, this becomes 372.5 is equal to n minus 1 into 2.5. Solving for n, we have 372.5 by 2.5. N is equal to 372.5 by 2.5 plus 1. So that comes to 150. So n is 150. So the number of terms is 150. Having done that, so we have seen the number of terms, the first question, the answer is 150. Now let us go to the second part of the problem. It is asked to find the sum of all the terms. So we have to find S 150. We know that the formula for sum of n terms is n by 2 into A, the initial term, and the last term. We have discussed this in the module 2. So now here n is already found, which is 150 by 2 and A is 4 plus L, the last term is 376 and half. Now let us calculate, and now on calculation you will find that the sum to 150 terms is 28,537.5. So that gives you the answer to the second one. Now we will have to find the 80th term, that is T80. The formula for Tn is A plus n minus 1 into D. A is 4 in this case, plus n is 80 minus 1 into D. Find the value for yourself and check your answer. Here D is 2.5. The answer comes to 201 and half. So that finishes this problem. Now let us move to see an application in arithmetic progressions. The problem is, suppose we invest ₹100 at a simple interest of 15% per annum for 5 years. The amount at the end of each year is how much for each of these years? That is, if n is 1, 2, 3, 4 and 5, at the end of the first year, second year, third year, fourth year, fifth year. So now what will be the interest? Let us calculate this. We know that we have to find out Tn here in this case. So here Tn is T1, T2, T3, T4 and T5. We know that the interest is 15%. 15% means 15 rupees per 100. So the common difference is 15 rupees. So the common difference here is 15. The initial amount is 100, that is what you put. So for the first year you get T1, which is equal to A plus n minus 1 D, that gives you A is 100 and the first n minus 1 into 15. So this is the starting period, this is the starting point of time. You get 100 plus 0 into 15, that gives you 100. So this is the starting period. So 100 plus 0 is 100. Let us find for the second term now. The second term here n is 2. So T2, we are going to calculate for T2 now. T2 is equal to A is 100 plus n minus 1, that is 2 minus 1 into D. D is 15 for us here, which comes to 100 plus 2 minus 1 is 1 into 15, which gives you 115. Let us read the problem now. The problem is, suppose X repays a loan of rupees 3,520 by paying rupees 20 in the first month and increases the payment by rupees 15 every month. How long will he take to clear the loan? So here in the problem, the initial amount that he is paying is 20. So A is 20 and every month thereafter he is paying 15 rupees. So it is an increment of 15 rupees that he pays. So the common difference D is 15. You have to find the time period during which he is able to repay this. So let us say this is unknown to us. So we keep it as a question mark. N is unknown to us. Let the period be N. So now the total amount of loan is 3,520. Let us now take this problem and solve it. Having known that initial amount is 20, common difference is 15, the term is n and the Sn, that is the sum to n terms, is 3,520. Let us now calculate the value of n from this. We know the formula now. the sum to n terms is given by Sn, which is equal to n by 2 2a plus n minus 1 d. We know all these terms. Now let us substitute these values in this. So it is Sn is 3520, which is equal to n is unknown to us, n by 2, 2 into a is 20 plus n is unknown minus 1 and d is 15. Let us substitute these values here. Now solving for n, 3520 is equal to n by 2 into 2 into 20 is 40. This is 15n minus 15, or n by 2 into 25 plus 15n. By cross multiplying 2 here, I have 2470 is equal to n into 25 is 25n plus 15n square. Transpose this 7040 to the other side. We have equation 15n square plus 25n minus 7040 is equal to 0. Now solve this is a quadratic equation. So we have to solve this using the formula n is equal to minus b plus or minus root of b square minus 4ac by 2a. Substituting the values here, n is equal to minus 25 plus or minus root of b square is 25 square minus 4 into a is 15 into c is minus 7040 whole divided by 2 into 15. And now on solving this for n will be 25. N is, sorry, it should be root of 400, which comes to 20. Discard the negative value. So the number of period here is 20 months. So this is the application of arithmetic progressions. Now let us move to the other application of arithmetic progressions. The problem is, a man saved rupees 16,500 in 10 years. In each year after the first, he saved rupees 100 more than he did in the preceding year. How much did he save in the first year? So the total amount in 10 years that he has saved is 16,500. He started saving 100 rupees after the first year. So this means that the common difference is D, which is 100 rupees. So the question is, you have to find how much did he save in the first year. So we have to find the value of A. Now here clearly this is Sn, which is sum to n terms. The formula for sum to n terms is Sn is equal to n by 2 2a plus n minus 1 into d. This is sum to n terms. Let us substitute the values that are given to us. Sn here, S10 is 16,500, that gives, and here n is 10, which is divided by 2. A value is not known, that is what we are going to find, plus 10 minus 1 into D. D is 100 here. Let us find the value of A. This is 5, 16,500 is equal to 5 into 2A plus 10 minus 1 is 9 into 100. So, now let us calculate the value of A. So, this is 16,500. Let me multiply this. This is 10A plus 9 into 100 is 900 into 5 is 4,500. That gives me, transposing 4,500 onto this side, it gives me 12,000 is equal to 10A. So, A is equal to 12,000 divided by 10, that gives me 1200. So, the initial amount is 1200 rupees. This brings us to the close of the module on arithmetic progressions. So, once we are comfortable with arithmetic progressions, we can apply them to our managerial problems like calculating interest, annuities, etc. Thank you very much and wish you a nice reading.